first year graduate students in electrical or computer engineering. Is that true? Yeah? Okay. Okay. So what I want to do here first is a little introspection. So we're looking back when we were little kids and thinking about what did you dream of becoming? Okay, that's why everyone has a piece of paper. And if you don't have a piece of paper, I can give you that. Or if you have a notepad, or everyone has a pen, I would presume, right? Okay, so just take a few minutes. Do you have a, yeah, you do. Do you? Okay. Let me just toss it. Okay. Okay, so take a few minutes and think about, you know, when you were a little kid, what did you dream about being? We want to have 10 volunteers. Okay, just take a few minutes, let's see. Yeah, it's 1 or 2, let's take 5 minutes or so. When you were a little kid, what did you dream about becoming? Welcome. If anyone says I'm an electrical engineer, I'll be surprised. We'll wait to see the 10 volunteers, what do they say? So the exercise is, you know, when you were a little kid, what did you dream about becoming? If you have like pen and paper or just something, we'll just ask for 10 volunteers to give their responses. So we're all doing an exercise. We are using pen and paper, writing down when you were a little kid, like what did you dream about becoming? A little exercise. Think about it.
Just thinking.
Anybody who has not signed?
These thought bubbles. I see all these little thought bubbles hovering around your heads. What did I want to be when I grew up?
is about yourself. You know what you want it to be. It should be easy exercise.
Oh,
Okay, I'd like 5, or what did I say, 10 volunteers who are gonna be the unshy. Okay, thank you. Can you give us your first name and Caroline?
Caroline.
Caroline, okay. What did you dream about when you were a little kid? What I wanted to become when you grew up?
I actually did want to be an engineer.
An engineer? What kind?
An electrical engineer.
Electrical?
Oh!
Let's give her a hand of applause for being the first volunteer. Okay, so you wanted to be an electrical engineer, and are you electrical or computers?
Electrical.
You're electrical. Okay, well, she dreamt and she's living it. Okay, very good. Thank you.
Fantastic.
Yeah, very good. That's funny. How about another one? Okay, what's your name?
My name is Neeraj.
Okay.
I thought about being a wildlife traveler.
Oh, what?
A wildlife traveler.
Wildlife traveler. Interesting. Okay, so like National Geographic, working for maybe National Geographic or something? Okay. So you didn't dream about becoming an electrical engineer? Okay, but somehow you're here.
Yeah.
Okay, let's give her a round of applause. Okay, how about another one? We've got 8 more. Yes, please.
Yeah. As a kid, I wanted to be just rich.
A what? Rich.
But what kind of rich?
Like an
Yeah.
entrepreneur, like toy seller or something.
Okay, okay. All right, well, okay, so maybe my speech is very pertinent to you. Engineer to business owner, maybe. Okay, very good, thank you. We have 7 more volunteers. Yes, sir.
Swimming to be professional mechanical engineer.
Professional mechanical engineer.
Mm.
Okay, and are you electrical or computer? Electrical, okay, okay. Okay, all right, very good. How about another one? Anyone else? We have 10 to go. Yes, please, 6 to go.
Scientist.
Scientist. Any particular type of scientist?
Well, when I was a kid, I really wanted to go into space.
That's very cool. Maybe Mars or just the moon, space?
Well, I used to watch a lot of Star Trek, but I just wanted to fly around in a spaceship.
Yeah.
They told me that, we should become a scientist. and
Yeah.
grow up.
Yeah, yeah, that's a good one. I like that. I like that. Very good. All right, 5 more. Who's gonna be brave? 5 more volunteers.
Something like police officer.
Police officer. Very different fields, I would say, right? And in your electrical or computer?
Computer science.
Computer
Computer
science.
science.
Okay. Okay, police officer, computer science, okay. I know they use computers, right, when they're tracking us down on the highway. We had like 5 or 6, when we were driving on the I-80 from Cleveland, right, the turnpike, there's like, my phone's always like, speed check ahead, and there's always someone there. They use those computers to track me down. Okay, very good, thank you. Let's give a round of applause. How about our, who'd like to go next? We have 4 more.
Everybody has.
Yes, please.
So me and my brother, we used to saw a lot of superhero movies and also like Transformers.
Okay.
So from then we planned to be something, we want to build robots and something like that from the very childhood. Then when I was teenager, my parents wanted me to be a doctor, but again I wanted to build something like bigger in robotics and something like that.
Okay.
So yeah, I chose like electrical engineer. Yeah.
Okay, so maybe you wanted to be an Avenger.
Yeah, something like
The next Black
build
Widow.
something automated or
Yeah,
something like that.
yeah. Okay, very good, thank you. All right, very good job. How about, I think there's 3 more. 3 more volunteers. You see, there's no right or wrong answer. We want to be scientists, we want to be police officer.
I wanted to be in army.
Army, okay. All right, you like the outfits and the militant, yeah, okay. All right, very good. All right, very good, and 2 more. 2 more. So for the folks that came in a little late, we were thinking, the exercise is that you're thinking about when you were a little kid, what did you dream about becoming? And now you all are either engineering or computer science. That's the exercise we're going through. So 2 more volunteers. Anyone? They're on screen. No? Okay. Well, it's okay. So what I wanted to talk with you folks today is that already we're seeing, even from childhood, you can want to be a police officer, you can be a scientist, you can be an electrical engineer and actually become an electrical engineer. But after you're achieving these degrees as electrical or computer science engineering, there's still a variety of options available for you. You don't necessarily need to go into traditional electrical engineering fields or computer science fields. And I'm picking up my phone, not to check a text message, but because there is on the way here, took a picture and I wanted to read what a traditional electrical or computer engineer would traditionally do. And what I will talk to you today is how to maybe move away from those traditional views, but you have the underpinnings and the background of that solid engineering degree to make those decisions, okay? It's very difficult for someone who may have a communications background or an art degree to be able to become an engineer, but you have the underpinnings of an engineering degree, albeit electrical, computer science, and then you can become an artist. Do you see? So it's the delta in the degrees. So what I wanted to read here, and it's on your building here, so electrical engineering in general uses principles of math and science to design, analyze, develop, and test components of systems from small devices. And some of you folks want to actually do that, right? And then with computer scientists and engineers design and prototype computer service devices, systems with a focus on mapping computing ideas into working physical systems. They design and develop software such as database systems, operating systems, and internet applications. And that is on the building we walked through that Dr. Kaur kind of took us on the longest walk of my life from the parking lot, and we saw these definitions, just joking. So with those definitions, currently, after you graduate, your first year graduate program, you have probably maybe a year, maybe a little extra if you take some time off or you did some internships. Based on those definitions, how many of you kind of high level thinking that that's what you want to continue doing? That those definitions that are on the wall. And which building is that? That was like this first
District Hall, first floor, no?
has those definitions.
Hallway there.
So I saw one hand. It's a pretty full room. Only one hand would agree with those statements, and that's what they kind of want to get into. Is that right? Or any other? Yeah, kind of. If you're on the fence. Yeah. So what I'd like to talk about is we have a few case studies. Okay, and these case studies are really talking about folks in my life, maybe not in my life, that had traditional engineering backgrounds. And this first person, or case study one, did have a traditional background in electrical based engineering. Not all of them will have it, but this person had a BS in electrical and electronic engineering. That's what they called it. You may say, well, I don't remember that one, that's not in the States, so maybe they weren't trained in the States. A master's of science in electrical engineering. And then this person did briefly embark on a PhD in electrical engineering. But, different things came up and they, only started that a little bit, but had other things in mind. Mr. B. And of course, this is an extreme, but he is an engineer to an actor. Anyone wants to be an actor? Yes, I would agree. That's a difficult life to live. You may be rich, to the fellow in the back in the red shirt, you may be rich. He's not paying attention. But you may be rich being an actor, right? But that's, it's Mr. B, right? So, you've seen him. He's an English actor, right? He's been in some of these movies, James Bond, Scooby-Doo, etc. And this is the extreme, but his roles are more the funny aspect, right? He's not a serious actor. He's a very funny actor. But my point in bringing him up is not necessarily he's just engineering that became something extreme. Is every degree has helped him. He's designed, when he was at Oxford, he's designed there was a impromptu stand-up comedian show that he created for Oxford. Like he designed that, he ran it, and he was the main actor. And you need to have intelligence to start these kind of things. You need to have the underpinnings of engineering, not necessarily electrical engineering, but the underpinnings of that design and development mindset. Okay, so this is just a funny, right? I mean, I'm not the biggest fan of Mr. Bean, but it's a great example that he is an electrical engineer, pursued even a master's, did a little bit of PhD, and that's when he finally transitioned, before he made that jump between master's and PhD, that my heart isn't in this. And we have Indian parents. My one parent is Indian, and my other parent isn't, but they both are immigrants. Myself and my two brothers are here. We're first born here. He was born in India. My mom is Eastern European, blonde and blue eyes, is my mom. And they're both immigrants. And why I bring that up is because sometimes our parents can kind of push us, like we need to be engineers or doctors, right? That's like a big thing. In a lot of cultures, not necessarily Indian cultures. But that's a big thing, and with him particularly, he felt right after his master's program that it wasn't behooving him to go into a PhD program. It wasn't in his heart. He liked comedy, he liked making people laugh, and that was his drive to go into something a little different. Okay? Let's look at our next case study. Okay? So this fella has a BS. In electrical engineering, an MS, so a master's of science, right, in biomedical engineering, and then a master's of business administration, so an MBA. Does any of your family, siblings or mom or dad have MBA? So it's all about you're managing a business. Okay, you're managing a business or you're a managerial role or something like that. Okay, this person has 20 plus years of entrepreneurial engineering focused on product and launch. So what this means is this person used their engineering and MBA to, at one point, was a vice president of a device company. So they were not only a VP, but then they were also doing the engineering, design, and launch of that product. At one point, that company had a private jet that he was able to fly people around on that private jet. Welcome. Okay? So this is another one. You can go into the engineering route, and if you ever wanted to maybe start a business or move away from the technical aspects of it, you're getting an MBA. This is actually very common in doctors. So doctors who are the traditional like MD route or DO route, and they don't want to see patients on a daily basis, but they want to do more of the management aspect, they go into MBA, and they're more into the running of the hospitals as opposed to interacting with patients on a daily basis. Patients are exhausting, right? And they want to move away from that. So it's a lot of engineers. MBA is a fabulous combination if you ever want to get away from working in the lab and design and development, but then moving into that managerial management aspect. Okay? And guess who? It's Anjali Kottha, famously known for being my dad.
I got something to prove everybody. You can pass on to everybody, whoever. This is my life.
Yeah, it's his life.
We
And so
don't
this
have
is
enough.
this is engineered to
You get them in
entrepreneur.
the car, they'll-
Yeah. Okay. So this is engineered to entrepreneur.
One for each table, I don't know, I don't know, 50.
Yeah. Okay. So he's the founder and owner of a consulting company. Supports multiple standards and models, which means that everything that we do, everything from hospitals to restaurants to cars that we drive, they work because they're based off of quality management systems and models, right? When you go to a Starbucks, even those are franchised, every Starbucks runs the same if you're in the US, right? You go to the front, you order your drink, you put the tab on your drink, you pay, you go down the same process. It's a quality management process, essentially. You have a lot of, we just drove by the Stellantis building here, right? This area is really big in car manufacturing. They have processes. And that is that company that he owns is what we're talking about with models and standards, that quality management system. He served as the president of American Society of Engineers of Indian Origin, ASCI. That's the organization bringing this speech here to you today. I'm not the director, I'm a director on the Michigan chapter, even though we're in Cleveland, but we don't have one in Ohio. We're trying to set up an ASCI chapter in Ohio. It used to be in Ohio, but it's since closed. He's been listed as who's who in America, an overall titan of industry and master of the universe. I joke that because his name in Telugu, he's from Hyderabad, Jagannatham, means master of the universe. So it's a joke. That's my dad. I love my dad. So that is my
How many
my
Telugu
father.
speaking people are here?
Woo!
Wow,
Not to single out anyone else though.
that is Jagannatham, master of the universe. Nobody can take over.
So that's that. It's a family joke that it's like whenever my dad makes like a proclamation, like we will go here as a family, like we're always like, okay, master of the universe, we got it. It's like leave your Triton like here, or your, whatnot. Okay. So again, my point in bringing this up here, and he's here with me as a support. We have this company together. It's his company. I work with him, obviously, and it's he wanted to, and he was an entrepreneur all of his life. I think, in the early years, like when he was an undergrad in electrical, and then he did his master's in biomedical engineering, then another master's in business administration. It was that period of between like the undergrad and master's, he came here in the States, because he did his undergrad in India. And it was that sense of, yeah, it's great working for someone, right? Designing other people's products and working under someone, but then it's like, I want to be my own boss, and I want to design products while being my own boss, right? And that's where that engineer to entrepreneurship, but he couldn't be that, I don't think, if he didn't have that engineering school is no joke. We all know it. There's different types, right? I'm a biomedical engineer. It's different than chemical, than mechanical, than electrical, but there's underlying pinnings of the design and development brain. And that's what we're talking about here, is you have inherently, by getting this far through your degree as a graduate student, you have a lot of options because you already know how to think like an engineer. It's a different thinking process, okay? It's a very different thinking process to be able to have problems and come up with solutions. And you're able to come up with solutions because you're able to design and develop and use and organizing the thoughts in your brain enough to come up with a solution of designing a circuit board or something, or a navigation system or something like that in a Mars rover, right? Versus designing a company, how the company would run, how to manage that, there's a different strategy, corporate culture, it's all of those kind of things there is a relation. Okay. Let's move on to case study 3. Okay, so this person has a BS in biomedical engineering, and then was like, I want to switch to do a master's in chemical engineering, and then switched back to a PhD in biomedical engineering. Okay, they were separate schools, different engineering buildings. Okay, so this was this case study 3. Okay, so has worked in device design, some more of the traditional route that you would think in a biomedical engineering program. For post-bachelor's and then during master's, this person worked at Lerner Research Institute, which is a institute that's part of Cleveland Clinic main campus. So they do a lot of research there that then the Cleveland Clinic main campus actually uses. So they have animal research there and other research there that they develop there, and then it's actually implemented with patients at the main campus. Designed and synthesized multifunctional nanoparticles for targeted drug delivery for their doctorate research. So even if you're seeing post-bachelor's, they worked in device design because they were bachelor's in biomedical engineering. Then masters moved on to some orthopedic, but then also using some other kind of fluidics for the chemical engineering. And then their doctorate, they moved on to nanoparticles and be able to deliver drugs in those nanoparticles, okay, for like specialized treatment, targeted treatment, we call it. Okay, so this person is known as my husband, and for identity, I didn't take his picture there, but engineer to software design and sales support. And this is not sales support, this is engineering. They call it engineering sales. You have to have that engineering background in order to sell a product. It's not your traditional selling of, I think of a good example off the cuff, but this is engineering sales. You need to have a thorough knowledge of the product and the engineering behind that product to be able to sell the product, okay? So that's what he does. So he's currently a VP of Product Innovation at a cancer-focused software company in downtown Cleveland. And they primarily design software products and algorithms that oncologists will use. So they work with the Mayo Clinic, they work with the Cleveland Clinic, they work with UCSF, they work with, trying to think of that, I'm losing the track of the name, but these are the types of people that they work with, oncologists. And they use this software that they're designing, that he's a VP of Product Innovation, and they use to be able to track specific genomic mutations for cancer patients. So this is not cleared by the FDA, but this is really the last draw. When people have cancer, I don't know if you're aware of it, usually they're either lucky enough to get onto a clinical trial because they get the latest and greatest drugs, or they are, they're just given like radiation or chemo. It depends on each metastases is kind of targeted differently. And when that doesn't work, and oftentimes it doesn't work, or it works for a little bit and then people go into remission, they will then have a genomic sequencing done. And it's not FDA cleared, but this is actually what Angelina Jolie did a few years ago. She found out that she had the HER+2 gene that her mom had, and her mom actually had cancer from it. And Angelina Jolie did a test to see, and sure enough, she did have that genomic mutation, and that is why she proactively went through a double mastectomy. You folks know what that is, if not, look it up later. But that is what she went through because she didn't want to have the cancer. So this technology is able to track the genetic mutation enough to see if you have the mutation, and then there's targeted drug therapy that can be used to get that specific cancer under control. Okay? And yeah, he mostly plays with computers all day and draws on napkins. That's what he does. That's his new job. But so my point in bringing here is, yes, he did have the biomedical and chemical engineering background, but now has moved into software and designing and actually developing software. And he wasn't built a computer science engineer, but a lot of people have the propensity to learn something that you didn't maybe learn as an undergrad or a graduate student, right? He is very able to read things, study things, learn things, and able to learn on his own to make it to a VP of Product Innovation after being out of his PhD program for 8 years. He's only been out of his PhD program for 8 years, and he's labeled the VP of Product Innovation at this company. And the previous owner of this company built up a similar company in Cleveland. It's called Brulant, and he sold it for over like 200-some million. So that is the goal of this company, that CEO is trying to build it up to sell eventually to other Silicon Valley type of. So those are, another thing you can consider is, again, you have those underpinnings of design and engineering that can help you propel you. If you're a good learner, you know how to learn and not just memorize things, which I imagine if you're a graduate student at this point, you know how to learn on your own. Okay? Okay. Now, last case study, a biochemistry, BS in biochemistry, minor in French, and then a master in biomedical engineering. Okay. So this person designed and developed software programs for cardiovascular procedures used in the J5 CT scanner. So this is in the main campus, the Heart Center at Cleveland Clinic, main campus. They have your CT scans, your MRI scans for cardiothoracic patients, and there's certain software that's used to determine the amount of milligauss meters, which is the amount of radiation used for CT scans, and MRI is magnetism, but there's also amount of fluid and contrast used to be able to visualize the cardiothoracic region. And even 20 years ago, all of us in the room would have the same amount of radiation and contrast used if we were to visualize our heart. Now that shouldn't be the case, and why is that? Why do you think we shouldn't all have the same amount of radiation and contrast for a simple scan? Sorry, I know you guys aren't biological, medical majors, but why do you think that's probably not a good thing, that all of us would have the same amount of radiation and contrast and are going through?
People who are different ages can only handle so many doses of radiation, and hurt
Yeah.
them more than it could help them.
Yeah, it's really linked to BMI, and we know BMI. Some folks are like BMI aren't a good measure, but they really look at the height and weight of someone. So all of us are different sizes, and we should not be having the same amount of radiation nor contrast, which is a pretty heavy on the kidneys. To your point about the age, right? If you're older, or some people are maybe kidney compromised, But what this software did was able to use, as long as we had some, PHI, we had to know their height and their weight. This software was able, that this person designed, was able to calculate how much radiation and contrast they would need to get a CT scan of the cardiothoracic region. So specialized targeted medicine. Okay? And guess who? It's myself. I think that's an AI generated picture, but kind of still looks like me, right? So engineer to business owner. We'll get to that in a second. But I actually had a dream. Yes, go ahead.
Just want to know that person who just saw here on this side, she has a French, a minor in French.
Mm-hmm.
She's signing a contract today by a multi-billion-dollar company from France for a technology that they are developing. Our company is selected to certify them. And the credit all goes to Anjali Kottha. She negotiated a contract for us.
Thanks, folks. All right. So yes, so that was me. That was my story. And you might think, okay, biochemistry to biomedical engineering. That was a jump. That was definitely a jump, right? But I really had a dream about going to medical school to be an MD. And I put MD because anything but an MD in my undergrad brain wasn't enough. Meaning a DO, which is like the same thing as an MD, right? I don't know if anyone uses a DO. It's the same as doctor of osteopathic, but they're viewed as an MD. You go to Cleveland Clinic, you go to a local hospital here, they do everything. There's surgeons who are DOs. So it's for me, I bring this up because my brain was focused on the title. I wanted to be an MD. I wanted to help people, of course, right? But I was focused in undergrad, that's where my brain went. I know medical doctor, we have doctors in our family, in our friends circle, and it's a very prestigious name, but then did I really want to do it, right? And it kind of comes back full circle when I was talking about something my parents wanted, like I heard in the audience today, my parents wanted me to be an engineer, or my parents wanted this and that, like, what do you want? And so here, I had a dream to go to medical school. While in my master's program, so doing my master's in biomedical engineering, I applied twice, did not get in. Did not want to pursue a PhD. I saw that at that point, it was my boyfriend, which is now my husband, did not want to pursue a PhD. I saw what he was doing, and he was living in the lab, basically. And it's just a lot of failure and failure and failure, and eventually you may succeed as a PhD student. Father offered an opportunity of a lifetime to join his company, and currently a VP of Technical Solutions there as a quality management consultant, and then a co-founder and president of our sister company, EPX Technologies. Okay, and the rest is history. So this is a little different. I mean, jumping from something like a softer science to an extent of being a medical doctor to going into doing some design work and product and software development at the Cleveland Clinic for a few years, and then moving into completely quality management systems. But what we actually do is work with companies who design software and products for the US government. And we audit those companies. That's what we do as a quality management system. So let me just expand that a little bit. So the US government, so think of the DoD, think of NASA, think about VA, think about Center for Medicaid and Medicare Services, all these systems that make the country run, right? They depend on other companies called government contractors. So these are companies, so think of, anyone heard of Lockheed Martin, Northrop Grumman, General Dynamics, PricewaterhouseCoopers, they added an S, a son joined, I think, daughter joined, right? Those are all companies that do work for the US government, so they're called government contractors. Those are our customers. So we actually had a subsidiary of Lockheed Martin as one of our customers, right? That was a subsidiary. And Leidos, that was them, they were purchased by Leidos, and that's our customer. So we prepare them, and we audit them against various quality management systems for them to able to continue doing work with the US government. So even if you go into a DoD facility and you may have to step into the restroom and wash your hands with soap, that soap was procured with a government contract. The government doesn't do anything on the road. Everything they do is purchased through an RFP, request for proposal, And that's how they got the soap, the dial soap in the DoD building. Okay? So what does a quality management consultant do? Lots of things. Okay, so we're gonna talk about one such thing that we do, and that pamphlet that my dad gave you is kind of the whole gamut of what we do, but you always wanna think it's based on quality management consulting. So my analogy of why Starbucks is the exact same as all the other Starbucks. Actually, I went to a Starbucks in Prague, which is in Czech Republic, is the exact same. So I think Starbucks everywhere is the exact same, regardless if you're in the US or in Prague. The exact same, because they have a quality management system in place, a standard process in place. And what we do is we don't work with Starbucks, even though I thought that would be really cool if we ever got a contract with Starbucks. It would be fantastic, get free lattes for life. But you would have we work with customers that require these processes, government contractors, and the government wants to work with them if they have a standard, steadfast quality management system. They do things properly, right? So if you're gonna be building an F-16 for the DoD, Boeing, or let's see, Lockheed is probably doing this, or Northrop Grumman, they need to be following certain quality management systems and processes if they're gonna be designing and developing these F-16 airplanes. And Lockheed Martin is certified to some of those standards that are in that booklet, okay? Okay, so what we're gonna be talking about next is a little thing that's been happening in the US. It's probably been happening more so in the pandemic timeframe. I think he thought this talk was boring. Anyways, but I'm just joking. But so this issue that we've been seeing has really been coming to the surface really since the pandemic, and it's a rise in counterfeit and fake products. So everyone knows. Has anyone flown into New York recently? Either like JFK, LaGuardia, they had to go into Manhattan, and you can. I mean, first, has anyone been to Manhattan before? Yeah, okay. And what do you kind of see on like, you're not gonna see it by like Wall Street, but like when you get into something, you're not gonna see it on like the Upper East Side, but what do you see on like the streets? Like you can get pretty much anything in New York, right? You can get, in theory, a Gucci bag for $20. You can get Valentino loafers for $50. But is it actually Valentino? Is it actually Gucci? No, it's just like Gooch. It's Val. It's not the actual brand, right? And we know this. We've been seeing this for a very long time. But there was a bust in November of 2023, so that was just a few months ago, right? So there's 2 people who were arrested in one of the largest seizures of counterfeit goods. Okay, this is from CNN, so this is what the actual heart of the warehouse looked like, and maybe you recognize some brands or logos there. Okay, but it's including knockoff designer goods, so the Gooch as opposed to the Gucci, right? And it was estimated to be more than $1 billion. New York officials found out it was over $1 billion of counterfeit products. I would not want a counterfeit product. I would not want a counterfeit product if I was paying full price and then getting a counterfeit product, right? Because what happens here is folks will go here and buy the counterfeit product and then go on eBay or other places that don't do the verification and can sell these counterfeit products at full value. That's how it is really a bad thing, okay? And how about this, when it hits closer to home, okay? This article came out when I was actually in November, when I was in Dallas working with Johnson & Johnson. I do some FDA audits with them, type of FDA audits. And I remember seeing this as I probably like on the way home from the airport or the way to the airport when I was in Dallas. And United Airlines discovered dubious or fake or counterfeit products, whatever word you want to use, in their engines. And when was the last time you flew on a United plane? Anyone flew recently? guys are college students, you guys don't fly. Anyone recently? No, flew anywhere? It's spring, you guys are doing
Year back.
your spring
1 year
break?
back.
Hmm?
A year back.
1 year, 5 year back?
1 year back.
1 year back, okay. Well, and I flew to Dallas and I was on a United flight in November, and this article came out. So United Airlines discovered dubious parts in 2 aircraft engines, adding to the list of carriers worldwide that have found bogus components from their supplier AOG Technics. Okay, so it wasn't United Airlines' fault necessarily, but they work with AOG Technics, and either AOG Technics is under investigation to see if they were, doing this on purpose, or was it something that just was overlooked and, wasn't like malicious, but it's still a counterfeit product. So who wants to fly 30,000 feet up in the air with a fake engine part? Not me, right? And it may not be necessarily fake, but it could be a part that was deemed as out of commission or deemed as being, the product is no longer valuable. If you think of like an O-ring or think of something for the engine, and then someone takes that part, maybe redips it in something and brands it as a brand new part. The failure, the aspect of the failure ratio is going to be deemed, incompetent, right? It already was deemed as being an end-of-life product. So the parts were discovered in a single engine, each of 2 aircraft, including one that was already undergoing routine maintenance. And there's the Chicago-based airline, and this AOG Technics is under investigation. Okay. And then when it hits home, a little closer to home, when we have fake medical supplies. Okay. Does anyone wear N95 masks during COVID? You had it, some wore those masks, or some just wore like the 3-ply little thin like blue masks, right? So with counterfeit PPE, personal protective equipment, ran rampant during the COVID timeframe. And it did because the factories weren't able to produce enough PPE. They were getting less than material and equipment, and there wasn't enough people to make these things, so there was some counterfeit products that came in, and they were flooding the market, undercutting American producers, but especially it's concerning that there was fake masks. So think of sitting next to your mom and dad, or someone that in a car, and they had COVID, and you're driving them to the hospital, and you had a N95 mask that was fake. You weren't actually protected against the highly contagious person who had COVID-19, right? That's what we're talking about, or fake counterfeit other products like syringes or insulin syringes or those kind of things that's every day is happening. Every day this is counterfeit products. So we have to be particular when we talk about what is maliciously tainted and counterfeit means. It's a very specific definition. So if we're talking about a maliciously tainted product, the product is produced by a provider and is acquired through a provider's authorized channel, but has been tampered with maliciously. Okay? And then if it's a counterfeit product, the product is produced other than by or for the provider, or supplied to the provider by other than a provider's authorized channel, and is presented as being legitimate even though it is not. Okay? So what is the US government doing about this? And this is how it comes full circle into our lives, how it impacts my life and Jack's life and our company, is that there's bipartisan bills being passed aimed at making sure there's no counterfeit medical supplies. But more importantly to us is NASA. Anyone's heard of NASA? That's the whole reason why you dreamt about this, right? So NASA is strongly endorsing this quality management system, right? So all the systems that we deal with on a daily basis. And it's about mitigating maliciously tainted and counterfeit products. Do you think if you were traveling to Mars, I don't want to single you out, but imagine we're going to Mars and you are, there's an O-ring issue with one of the space shuttles. What happens? Is that really a safe? Yeah, you have the ocean under you. The ocean will catch you, I guess. But what do you think? Do you think NASA is right for having this standard that's going to prevent maliciously tainted and counterfeit products if they're designing a space shuttle or something? We want to have something like this in place, right? This quality check, probably. So in late February, and we're actually March, but they haven't launched it yet. I created this a few days ago. But so there was a big proposal that was dropped called NASA SOUP 6. And our customers, which are government contractors, are going to be bidding on this contract. And NASA is requiring those customers. So let's suppose Lockheed Martin is going to be going after this contract. They would be required to have this ISO standard to prevent or try to greatly reduce and mitigate maliciously tainted and counterfeit products. Okay, so what is it? It's the standard ISO 2043 is a standard that really started from the Department of Defense and NASA. It was launched to reduce the threats of maliciously tainted counter products, and this is specifically to NASA. There's other initiatives for other organizations. It's a private and public sector that's really NASA and Air Force. That's if you're buying commercial off-the-shelf products, COTS products for NASA, such as like software, hardware, servers, webcams, whatever you're building. It's NASA needs this equipment to run their systems. We want to make sure you're implementing these best practices, this ISO 20243 quality management system. And what do we do around it is we prepare organizations to be following these best practices, these quality practices. Some of them are, do you cross your suppliers and cross-check their suppliers when they're building? So AOG Technics, for example, they should have followed some best practices before selling to United dubious parts to the engine that could have killed 300, how many people are on a plane? 300, 350 on one of those bigger planes. Okay. This standard also encompasses, a set of standard guidelines, but then also an assessment procedure. So a third party auditing, making sure that they're following these procedures. It's one thing to be following it, but when a company says I'm following it, and there's an element of bias there, this assessment procedure, part 2, is really what we're talking about here, is being a consultant for that standard. Okay, so what types of products does this encompass? So think of the customer or acquirer as NASA, and then integrator, component provider are those other types of, maybe they're designing the hardware, but then the integrators use to add in all the different pieces and parts and whatnot, and then that's ultimately shipped to NASA. So that's how you want to look at this graphic, is really, these are all the different players that could be involved when working with NASA. Okay, and that is what we do as a company. This is what we do. There's a new standard that comes about. We learn through these standards oftentimes through our customers or through other grapevines, and we prepare companies to go through one of these systems. So that is what our company really ultimately does. So it uses aspects of engineering, design, development, because these standards and processes need to be built in order to consult a company and prepare that company against these different standards. Okay, I'm just conscious of time. So what I want to just say in summary, if you get one thing out of this talk, one thing, we talked about a lot of things, is Henri Matisse said, I don't think outside the box, I think of what I can do with the box. And the box for you folks is what? What is the box for you folks? Your degree, exactly right. That's the box. It's not what you can do with biomedical engineering degree, or Mr. Dean did electrical engineering. It used that box, that platform, that strong education to teach you how to learn properly, problem solve, and design and develop, to then do something differently if you don't want to be an electrical engineer, right? I'm not trying to persuade people not from being an electrical engineer or computer engineer, right? But when I ask the question, how many of you folks actually want to follow this definition that's on your hallowed halls down below, right? Those definitions of what an electrical engineer is and a computer science engineer is. Only one person raised their hand saying, yeah, that's what I want to do. Meaning all of you are still thinking about what you want to do, right? So there's a lot of different ways to use your degree. And the last thing I want to say is just be creative and open to different opportunities. Actually, my dad just said this on the way here. usually I'm like in La La Land driving with him, and you said that the diversity brings that maturity. And what that means is when you try different internships, different this, working with different people, sampling different areas, you get a sense of what you like and see if that's what you want to do for your life, for your career. Now is that time to really do that investigative analysis of, do I like what I'm doing? Could I see myself doing this for all? Because there's going to be a certain part in life when it's not going to be such an easy career flip, right? When people start having families and all those kind of things, it's like usually don't make a career flip when you're in your 50s. You got to do something completely different, right? It's kind of like now you got a taste of what electrical engineering or computer science engineering is, and it may be for you, may not be out for you, but think outside the box and think of what I can do with the box. Okay. Any questions?
I want to give you this as my gift to you. You can use this and record, tell everybody what's in the one you talked about, OT, the NASA project. This is the standard I want to give it to you. Let all people know that you can reach her and see what is in there. It might be of interest to you. Then if anybody has to write a master's thesis or anything, that can be used in this material to write your thesis and any project report and everything. But that's a real working standard. NASA developed this and we are certifying to that standard. All the products that we buy, they're all under this standard.
But the standard was valued by NASA.
NASA, right. That's what he was telling all the statement, all NASA endorses for safety, reliability, for trusting technology. Those are all coming from this standard.
So the job of your company is that all the government contractors
Have to be
should abide
certified.
by this,
Yeah.
by this standard. They
Yeah.
train them and certify.
Yeah, NASA, DHS, Department of Human Services, Homeland Services, NASA, DOD, and all federal governments require this standard to be in place for anything the government buys. And our company approved by the agency to certify. Anjali is a certifying auditor, I am certified auditor. We have two other people. So that's our job, is to prepare them and certify them. But that all coming from electrical engineering. My degree is back home in India, was an electrical engineering degree. So I can understand each and every design principle that's involved here to design what I'm doing as a business model. But
Thank you.
I thought your students might like to
Yeah, you will.
keep it with you and then circulate it to whatever it's a public available
Yeah.
document actually.
If you or anybody wants to explore it, you can borrow it from
Yeah.
in my office. Okay?
Yeah, that's my
Great read.
support from you. Okay.
All right, wonderful, folks.
Any questions?
Any questions? Sure.
Just a clarification. So
Yeah.
like your company would like work with places like Boeing, right?
Yeah.
So the DoD would give them a contract and then
Yeah.
you just verify that Boeing did that correct or something?
Yeah, so.
We qualify them.
Yeah, yeah. So let's suppose, let's use Boeing. Yeah, so let's suppose
Does
there's
the
a.
DoD hire you or is the
They
Boeing?
hire Boeing. And in order for Boeing to get
DOD
hired by the
does not hire
DoD.
us.
Yeah, go ahead.
DOD wants a contractor to be certified.
Yeah.
So their product can be trusted.
So DoD, let me just explain this, Pop, hold on. So a DoD wants you to build a F-16. They will send out a request for proposal, RFP, and hundreds or thousands of companies want to get that job. And to qualify for that job, they need some of these standards. And we prepare those customers to be qualified to those standards so they become more competitive. And they can outcompete those other companies. But these are, I mean, there's like hundreds of thousands, there's over 300,000 government contractors in the US.
Cause I'm gonna be the one that sends the contract out, so I'm just trying to understand it stuff, like understand it more.
So contractor is selling to the government. To sell the government don't buy them directly until they are trusting the company. You don't go, just like the pictures you were showing you, the counterfeit products, those products have to be certified.
Before the government wants to buy those products.
If the government wants to buy the product.
Okay.
Does that make sense?
Yeah.
If not, keep asking, because it's a
Okay,
good
so
question.
I would make sure that.
In a gist, you come before any contract from the government comes in.
Yes.
You certify the people who makes those products.
Yes.
And then since they have the certification from you.
Yeah.
Now they can apply for those.
Yeah.
Products.
Yeah, so let me
Yeah.
just go through an example, so this
Yeah, for
NASA's.
third-party auditing company, third
Yeah.
party,
Got it.
Yeah, so this,
third-party auditing company.
yeah, so
By
this
the way, I'm
NASA.
also going to give you some
Just good.
If they need any information, you can contact me if you don't get the flyer, or all of them. I have a lot of stuff in the car, but just I'll leave the cards here, if you need more, we'll give you. But anybody wants to reach us for, you can advise them in any project they want to make. We have plenty of opportunities for you guys.
Do you also offer internships?
Yeah.
Internship is another thing I'm glad you brought up. We are offering our internship program through ASCI, American Society of Engineers, whom we are volunteering to be. And that program is available to all of your students from your department in the whole College of Engineering. But the chapter is going to be open, and she is opted to be the guide for the
Student chapter.
the chapter. We're opening a student chapter here. So similarly, that's something of any, okay?
Yeah, so I just wanted to talk a little bit, so the NASA Soup 6 it was supposed to drop in late February, like yesterday was February, right? We're thinking it's gonna be maybe that March timeframe, and we've already certified some of our customers in like November, December, January, because they knew they want to go after this. So that's a connection. They hear about this pipeline weeks and months and years ahead of time. Like companies have their BD pipeline for like years in advance. And they knew about this contract. This is it's called IDIQ, meaning, was it indefinite quantity, indefinite?
Indefinite quantity in the IDIQ, indefinite,
Anyways, but it kind of puts you into that playing field, so you can go after all of this work if you win this contract. So they all knew this was coming out, so we certified them like months before. That's how our cycle is, really.
So there's another question, like, you said some companies, they are government contractors, but they already have a product.
Mhm.
Okay, so then you make sure that their product meets your specifications.
Yeah.
Yeah.
The second question is, if the government invites some like RFP proposals,
Mhm.
and then even, so that they don't have a product, they have to develop something, proposals.
Yeah.
So even for submitting a proposal, you are saying, you have to know that this particular entity is, their proposal is meeting the guidelines of this
Yeah.
ISO, and they are eligible to submit a proposal to
Yeah.
the federal government.
Yeah.
Or not.
Very true. There are two sections in it. If you look at it, there are two sections in it. I think I was that in one of the slides. Part 1, Part 2. Part 1, we are certifying the product. And that product could be IBM or General Electric, Lockheed Martin product design. That's one section in there. After that is designed, they can directly supply to the government. But some other customer who does not, some other contractor who does not have that product, but government wants to buy from them, then they will go and get that product already certified. And then they have to be certified for the reliability of their delivery. There is a supply chain security. That is the second part. That's the second part. Part 2 is the supply chain, not product design anymore, but the deliverables. While they are delivering, while they are shipping, they're not doing any malicious dictating in their process. For same reason that what she was mentioning, it's reduction of the price. So this standard is addressing both the issues under Part 1 and Part 2.
Okay, good question. Anyone
You seem to be a lot of interest here. Let's find out some more about it. We can call you. We'll help you to get where you want to go. She's the guide.
I just met him this morning.
Yeah, so folks, here's my contact information. Do you have any questions, further questions? Want just, hey, this is where I've been at, this is where I'm thinking about going, but I'm not sure. Do you have any connections for, maybe not an internship with us, but maybe someone else more local? Like, we have a lot of, we have 120 customers, a lot of them are in DC metro area, but I'm part of ASCI, American Society of Engineering of Indian Origin. My dad is too. So it's not always, maybe we won't have an internship, but we can connect you or just help guide you. Because that's the biggest thing that I don't think is enough at university level, is we know the traditional route. If you can be a biomedical engineer, you design devices at Boston Scientific, Johnson & Johnson, wherever, right? You're a chemical engineer, you make perfume, oils, emollients, those kind of things, right? Those are your standard ways of doing things. But it's just not talked enough, I think, of the different options you can have. And there's a lot of different options you can have if you're not interested in doing what you've studied so far. So folks, yeah, contact me, email, text, phone, call, whatever.
But these PowerPoint slides are already on the blackboard, so this information will be.
Okay, wonderful. Well, thank you, folks. Thank you.